We're going to talk about different types of asymptotes now. Instead of vertical and horizontal asymptotes, we can also have slant asymptotes, also called oblique asymptotes. And these are just straight lines that are not horizontal or vertical. So here's the definition. The line y equals ax plus b is a slant asymptote or oblique asymptote of the graph of y equals f of x if y gets closer to ax plus b as x increases or decreases without bound. In other words, y approaches ax plus b as x approaches infinity or x approaches negative infinity. Let me just draw a quick picture of what this really means. So we have a graph, and all it means is we have something like, some slanted line here, okay? And our function can do all kinds of things. Maybe we have a vertical asymptote, okay? And so we could have a function that kind of follows these asymptotes, okay? Something like this, and something like this, okay? So that's just an example where this line right here is a slant asymptote or oblique asymptote. Okay. Now the question is, how do we find slant asymptotes, or how do we find oblique asymptotes? And this comes down again to the degrees of the numerator and denominator. Now the first thing to know is what to look for to know that you'll even have a slant asymptote. And that is if the degree of the numerator is exactly one more than the degree of the denominator, then the graph of the function will have a slant asymptote. And to find that slant asymptote, we do the quotient, okay, after writing p over q in proper form. What that means is that we would do long division here with p divided by q. We do our long division, okay, p divided by q. We go through, and up here, okay, this is the quotient. This is the slant asymptote. So after you go through the whole thing, whatever ends up here is the equation of the oblique asymptote.